Hi friends, in this particular video tutorial we are going to learn about some of the basic geometrical concepts and primarily the straight lines. So before studying and the going to learn some of the geometry, let's first of all revise the coordinate geometry which we have learned in earlier class. So I would like you to recap your distance formula, which that is if the 2 points are given as P x1 comma y1 and q is the second point x2 comma y2, we have the distance as x2 minus x1 the whole square plus y2 minus y1 the whole square. The next is the section formula, that is if we have 2 points p and q and we have a third point which divides these two particular points in two segments whose ratio is m is to n, then we have the coordinates of that particular point. Say if that point is called k, the coordinates of the point are given by mx2 plus nx1 upon x m plus n and my2 plus ny1 upon m plus n. Next is that of the midpoint formula, that is to find the coordinates of a point which divides the line joining two fixed points, that is say p and q, uh, in two equal halves is equal to x1 plus x2 by 2 comma y1 plus y2 by 2. The next is that of the formula of the area of the triangles, which I'm not going to write as it's a bit tedious. So do have a look at this particular formula. Okay, so after recapping all the important things in your coordinate geometry, we'll move on to learn the first basic concept, that is slope of a line. So we take a particular pictorial representation here in which these are the coordinate axes x and y, rectangular coordinate axis, and this is a straight line. So let this particular angle be equal to theta, that is the angle made by the this line with the positive direction of the x-axis in anti-clockwise sense, that is in this particular direction, is known as theta, and the tangent of this angle, that is tan theta, is called the slope of the line. There are certain important characteristics to define a standard line, and the slope of the line is one of the important characteristics of them all. So the angle is this. Okay, so after we have known what is a slope, let's try to calculate what is the slope of a particular line. Let's say we have 2 points on a line, that is p x1 comma y1 and q x2 comma y2. So to calculate this particular slope, that is we want this particular angle, that is theta. So we know from our previous knowledge of trigonometry that tan theta is equal to the length of the perpendicular upon length of the base. So perpendicular here will be equal to this distance, that is y2, this particular distance, minus y1, that is this distance. So we have the length of the perpendicular as y2 minus y1 and the length of the base is equal to x2, that is this particular distance, minus x1, which is this particular distance. So we'll have the tangent of the line, or the slope of the line, denoted by m, is equal to y2 minus y1 upon x2 minus x1. There's another case when the angle made by the line is obtuse. So when the angle made by the line is obtuse, we'll have the triangle as this, and this particular angle will be theta and this particular angle will be pi minus theta, as these two angles are supplementary. By since this line is drawn parallel to this line, we have this angle is also equal to pi minus theta. So we'll calculate tangent of this particular angle. So tangent of this particular angle will be again this particular distance minus this distance. So we will have y2 minus y1 upon this distance, which will be equal to x1 minus x2. So we'll have x1 minus x2 here, and this will give the tangent of this angle, which is tan of pi minus theta. So as you might know, or just look into the tutorial on the trigonometric ratios, you'll see that tangent of 180 minus theta is equal to minus tan theta. So you'll have here minus tan theta. So if you take this minus on the LHS side, you'll again get the same formula, that is m, or the tan theta, is equal to y2 minus y1 upon x2 minus x1. So the slope of the line in all the cases is equal to these, y2 minus y1 upon x2 minus x1. Some of you might be wondering that if we make what happens is the angle exceeds 180 degree. So just try to make a line with which you think exceeds this angle. So let's say if you make this line, so this line will start the other part of the line will start coming in the first quadrant. So will the angle will be made by the other part of the line and not this angle. So we'll have tan theta of this angle and not of the other. So we'll always have the angle or the inclination of the line between 0 to pi. Okay, so now after we have looked into what is the slope, we should move to one of the basic things when of two lines, that is parallel lines. So as you might know that if two lines are parallel, then the corresponding angles are equal. So this particular angle will be equal to this particular angle. So we will have the tangent of this angle equals to tangent of this angle, that is the slope of this line and this line are equal, that is m1. If m1 is the slope of, let's say, this line L, and L1, and the slope of line L2, which is m2. So we'll have m1 equals to m2 as these two angles are equal. Okay, after we have looked into parallel lines, it's obvious that we'll go on to the perpendicular lines. So to see perpendicular lines, what we have is that, let's say this is line L1 with the slope m1, and this is line L2 with the slope m2. So what we'll have is like that L2 make an angle theta 2 and L1 make an angle theta 1. So we'll have, by the property of exterior angle triangle, that the angle theta 2 will be equal to 90 degree plus angle theta 1. So if we take tangent on both sides, that is tan theta 2 is equal to tan of 90 degree plus theta 1. So we'll have from the trigonometric ratio is example, we'll have tan of 90 degree plus theta 1 equals to minus of cot theta 1. And in the same chapter you will well known that cot theta 1 is equal to 1 upon tan theta 1. So what we'll have in turn is that tan theta 2 into tan theta 1 is equal to minus 1, that is equal to m1 m2 is equal to minus 1. Please do remember these two results, that is when two lines are parallel then the slopes are equal, and when two particular lines are perpendicular we'll have m1 m2 is equal to minus 1. We have talked about the slope enough. Let's get a general idea of the slope, some of the slopes. So we'll first of all look into what is the slope made by this particular line. So as you know that the value of x remains same in value of y remains same for all the particular points, let's say this point and this point. So we'll have slope of the line parallel to the x-axis as equal to 0, and the slope of the line parallel to the y-axis will be infinite, that is not defined. So what we'll have is that the value of x remains constant. So by the formula for the tangent, we'll have tan theta is equal to y2 minus y1 upon 0. So basically it won't be defined, or say infinity. So tan theta will not be defined, but as you can see the angle will be 90 degrees. Okay, after this we move on to finding the angle between two particular lines. We've seen two parallel lines and in perpendicular lines, but in general you will have more set of lines which are neither parallel nor perpendicular. So to find the angle between these two lines, what we'll do is that, let's say we this line as L1 makes an angle theta 1, and the other line L2 which makes an angle theta 2 here. Then let's say this angle is equal to theta. Again, by using the external angle property in this particular triangle, this, we'll have theta is theta 2 plus theta is equal to theta 1. So we'll have theta as equal to theta 1 minus theta 2. Now, if from the same trigonometric ratios, we can just work out what is tan theta. Let's take the 10 on both sides. We'll have tan theta is equal to tan theta 1 minus tan theta 2 upon 1 plus tan theta 1 tan theta 2. Now, as you know that tan theta 1 is equal to m1 and tan theta 2 is equal to m2. So the angle will be equal to m1 m minus m2 upon 1 plus m1 m2. So in this case, if the angle comes out to be positive, we'll have the angle as m1 minus m2 upon 1 plus m1 m2. As you might be wondering, the formula written here is has a bit of a difference. That is, it's written m2 minus m1 upon 1 plus m1 m2. So this particular angle, this angle is this angle. So we can have, if we had two other lines, say we had lines like these as this and let's say this. So this angle would then have been obtuse. So then this angle, this particular angle would have been taken. So what we do is that we take mod here to get a generalized formula, that is tan theta, that is the obtuse angle, and not this any particular angle. We have, if there are two angles being made by the line, this one and this one. So we have theta and theta as the acute angle, and the supplementary angle which it makes is equal to phi, which is obtuse. So the tan theta is given by mod of m2 minus m1 upon 1 plus m1 m2, and phi will be given by finding this angle and taking phi minus theta. After now we'll move on to one of the very important concepts, that is that of the collinearity. So first of all, let's look into what is collinearity. So as you can see, it has a word linear in this. So it means that when 3 points A, B and C are lying on the same line, let's say L2, then the 3 points A, B, C are called collinear. So to look into from the perspective of straight lines, what we'll do is that, let's say we have a straight line passing through AB and a straight line passing through BC. So as there's a single line which passes through ABC, what we'll have is that the slope of the line passing through AB will be equal to slope of the line passing through BC. So we'll calculate and equate the slope of the lines from the points AB and from the points BC. So to look into, we have to calculate, let's say the point A is x1 y1, B is x2 comma y2, and C is x3 comma y3. Then what will happen is that we let's calculate the slope for AB. We'll have y2 minus y1 upon x2 minus x1 and y3 minus y2 upon x3 minus x2. So this will be the particular equation, and this will be the concept if the 3 points are given and are said to be collinear.